Okay, let's look at the calcium fluoride crystal structure. It can be quite challenging at times, especially because sometimes you see it depicted one of two different ways. I like to draw it with the anions in the corner positions in a simple cubic lattice, but you'll also see it sometimes with the cations in the corner positions and in FCC type positions, and they are both actually the same. I want to show you that. So let's dive into it. All right, so first thing I'm going to do is I'm going to draw a little cube there, and the corners, the blue ones are the anions. Okay, and so you can see they're in a simple cubic arrangement. I'll add another one with a cation in the very center, right? So you can see those little orange lines I've drawn in there indicating that's in the very center of the cube. I'm going to turn that off just to keep things a little more neat. But you can see one cell with an unoccupied simple cubic site and one of them filled, and that matches the stoichiometry. We've got half as many cations as anions. All right, let's continue to build this out. And so we're going to build 4 there, and you can see I've spaced the anions out, or sorry, rather the cations, so that they're spatially distributed as far apart as they can, because they're like charges. They're going to want to do that to decrease the energy of the system. Now I'm going to start to build atoms out in front. I sometimes refer to these little cubes as subcubes because we need to actually reflect the staggered arrangement. So it's sort of like this, bottom and top, staggered positioning of the cations, front to back, back to front, left and right. And that's again because of this, the like charges, they're trying to space each other themselves out as far apart as they can. So let me just continue to build that unit cell there. And if I position, again, one more full and one empty interstitial site or subcube, we'll see that we've got now the calcium fluoride crystal structure. I could, say, as I sometimes like to do, shade in the front face of the cubes, the little subcubes, that have an occupied interstitial site. And so you'll agree with me, I believe, that half of these little subcubes are filled and half of them are empty. Okay, I'm going to turn that off to keep things clean. So that's fine. That is calcium fluoride as it's often depicted. What I want to show you now is how we can visualize this structure another way with an FCC lattice of cations. So we're going to take that same starting point, but now what I'm going to do is I'm going to position another, I'm going to continue the crystal above. So I've added another of these little subcubes above, again with that interstitial site occupied right in the middle, and turn off the orange lines to keep things neat. But you can see what I'm doing. I'm adding these things in, add one behind it, and I'm going to add another behind that. So I'm making this crystal a little bit bigger, one of these little subcubes at a time. Okay, so I've got 3 in a row here, going back in the negative x direction, and then I'm going to add another 3 along beside it like that, okay, all forming the same structure, and then I'm going to add this sort of wall, this big block along the side. So that was a lot of stuff we just did there rather quickly. What I can do to make it a little bit more obvious, I can just sort of make the original unit cell kind of faint, and you can see I've added just more of these little subcubes with the same alternating position of occupied and unoccupied interstitial sites along the top and the right side. I also need to add some in the back. I'll do that right now. And so now what you can see, I'll just move it around for a moment, is I've added on, if you will, this little shell over the top of our original unit cell. All right, so there's our original unit cell. And here's what I've done. I've just dropped this little shell on top of that, okay? So that is what I've done. Now what we need to do is look at the cation positions only. And what I can do, and this looks like a jumble here, right? But if I connect these cations together, which I'm going to do for you right now, I've drawn in these orange lines connecting the cations from adjacent unit cells. I see that I've got a little cube in there, and you might start to even see that the cations are in an FCC arrangement. If I just darken it up a little bit for you, and highlight a little box in the middle, and then what I'm going to do is I'm going to make the other ones a little more faint, okay? And it should become obvious what we've got there. You can start to see this other depiction here, and if I make the other ones even fainter, you start to see that in fact within that same structure, another way of looking at it would be an FCC lattice of cations with these within it a simple cubic lattice of anions. And in fact, the anions are they're tetrahedrally coordinated to the cations, if you wanted to consider their position within the cations. Right, that is, this cation is touching those four. The anions are touching, each cation is touching 8 anions, though. Remember that the anions are in a simple cubic lattice. All right, so that is calcium fluoride. Twice as many anions as there are cations. 2 different ways of looking at it. Thanks a lot.